So previously, we looked at the applications of matrices and solving systems of equations. What we're going to look at now is something called Leontief's technology matrix. And I can't pronounce that name properly. I know it, but let's just call him Leo. Okay, so Leo's technology model shows for agricultural products, to have inputs of agricultural products, you expect to have 0.5 units of agricultural products for every one agricultural product that we produce. And then we'd have 0.1 of manufactured goods and 0.1 of fuel to produce one agricultural product. That's how it kind of lays out. It determines the production levels necessary in each industry to support these items. So how many units of agricultural products and of fuels are required to produce 100 units of manufactured goods? So we're going to look through manufactured goods. I just realized I said it backwards. This is to produce an output of manufactured goods. This is how much inputs we would need. I said it backwards. Sorry. So to produce one manufactured good output, it takes 0.1 units of agricultural, 0.5 of manufactured goods, and 0.3 units of fuel input. I'm sorry, I had it backwards. We got it right now. So to produce 100 units of manufactured goods, remember, it's going to take 0.1 units of agricultural for 1 unit of manufactured goods. So we would need 100 times that 0.1. So 100 times the 0.1. So 10 units of agricultural. And then we would need fuels, 0.3. So 100 times 0.3, we would need 30 units of fuel. Sorry. Which production of which commodity is least dependent on the other two? So let's look at agricultural products. They need 0.5 of agricultural products and 0.2 manufactured goods, 0.1 of fuels. Manufactured goods, 0.1, 0.5, and 0.3. Fuels, 0.1, 0.3, and 0.4. So least dependent on the other two. Fuels needs 0.1 and 0.3 of the other two. Manufactured goods, same thing. Agricultural products only needs 0.2 manufactured and 0.1 of fuels. So agricultural is least dependent on the other two. If fuel costs rise, which two industries will be most affected? So which two industries input the most fuels? So fuel input, who's using the most input fuel? Manufactured goods and fuel. So fuel and manufactured goods. Oops, sorry. All right. So each industry has a gross production. The gross production matrix for the economy can be represented by this column matrix, where X1 is the gross production of agricultural, X2 is the gross production of manufactured, and X3 is the gross production of fuels. The technology equation for an open model is such. So it's got I minus A. What did I usually stand for? Oh, that was that identity matrix. A is going to be our technology matrix. X is the gross production matrix, and D is the final demands matrix. So let's take a look at what we have here. So this is that chart we were looking at. If we change it to a matrix, here it is, 0.5, 0.1, 0.1, 0.2, and so forth. If we wish to have a surplus of 85 units of agricultural products, 65 units of manufactured goods, and 0 units of fuel, what should the gross outputs be? So what we need on this is we need we're going to have I minus A times our variable matrix X. That's just going to have the X1s, X2s, and X3s. And we want that to equal D, which is the demand matrix. So this is the demand. It's what we want our final demands to be. So our surplus amounts. So the I minus A, that would be so we've got a 3 by 3. So we would have to put an I matrix, so an identity matrix, 0, 0, 0, minus that A matrix. Times X, which is X1, X2, and X3. And we want this to equal our demand matrix, which is the 8, 5, 85, 65, and 0. So we want that to be our demand matrix. So this is our I minus our A. So let's think about how we would solve that. If we have I minus A times X, equals the demand. Well, to solve it, we could do I minus A inverse times D. So I'm going to put those in parentheses. I is 1, 0, 0, 0, 1, 0, 0, 0, 1, minus 0.5, 0.1, 0.1, 0.2, 0.5, 0.3, 0.1, 0.3, 0.4. And we're going to do the inverse of that whole thing. So I've got parentheses around the whole thing. And then I'm going to do inverse times matrix D. That's 85, 65, and 0. So it ends up giving me the matrix 300, 400, and 250. What that's telling me is that I'm going to have to take, so X1 is 300, X2 is 400, and X3 is 250. This is telling me that our gross outputs should be 300 of agricultural, 400 of manufactured, and 250 units of fuel. Let's do it one more time. So a private economy with a lumber industry and power industry is the following technology matrix. So here's our matrix A. If we want to have a surplus of 30 units of lumber and 70 units of power, find the gross production of each industry. So we're going to be, this is going to be my demand function. So we're going to take the I minus the A times X equals D. Or our X is going to equal, so we're going to have to do I minus that A inverse times D. So X equals I minus A inverse times D. So our D is going to be 30, 70. So the I in this case is going to be a 2 by 2. Just 1, 0, 0, 1 minus our technology matrix 0.1, 0.2, 0.2, 0.4. And then we're doing the inverse of that whole thing. So go outside the parentheses to the -1 times matrix 30, 70. Okay. So 64, 138. So that means lumber. 64 lumber units and 138 power. If 5 more units of surplus power were required, how much additional output would be required? So what would that change if we needed 5 more units of surplus power? That would only change my D to be 30 over 75. So let's see. So I'm just going to take that and copy paste and change that to be a 75. So I would need 66 lumber and 147 power total. So we would need just a little bit more. We would need a little bit more lumber and a little bit more power. All right, our last one. The economy of a developing nation is based on agricultural products, steel, and coal. An output of 1 ton of agricultural requires 0.1 agricultural, 0.02 steel, and 0.05 coal. So I'm gonna do ag here, steel, coal, ag, steel, coal. So my technology matrix, to get an agricultural product, I need 0.1 here, 0.02 here, and 0.05 coal. An output of 1 ton of steel requires 0.01 ag, 0.13 steel, 0.18 coal. To get 1 ton of coal, we need 0.01 here, 0.20, and 0.05 here. Find the necessary gross productions to provide surplus of, so our D is 2350, 4552, and 911. So when we get our results, we're going to get how many ag, how much steel, and how much coal. So take a moment, try it. Pause the video if you want. So I got that we needed to produce 2,700 units of ag, 5,800 steel, and 2,200 coal.